Hey guys, today we're going to continue talking about Pythagorean theorem. We'll work through some word problems today, see how we can use this theorem to find missing measurements, missing distances, things like that. So if you want to follow along with the slides, you can. I'll read along as we go. So our first problem that we have here, it says Amelia has a rectangular garden with side lengths of 18 yards and 36 yards. If she wants to walk diagonally across the garden from one corner to the other, then how far will she walk? And we're going to round to the nearest tenth, so we will need calculators for this. And Pythagorean theorem can be really useful when you want to find certain measurements that might not be measurable. Like if you're dealing with like a big body of water and you want to know how long something is, if you have a right triangle there, you can use Pythagorean theorem to find certain distances. So here we have Amelia. She has a garden, and we're told the measurements of her garden. It's a rectangular garden, so it looks like this. And we are told the measurements of the sides are 18 yards, so we'll call this the 18, and 36, so this would be the 36. And we want to know her distance to walk from one corner to the other. So she wants to walk, let's say, from this corner across to this corner up here. And since this is a rectangle, some things we should know about rectangles: opposite sides are congruent. So this is 36, this is 18, and every angle would be a right angle. All of these would be right angles, but I'm going to focus on this one. Or you could really focus on this one. Either one's okay. But what we should notice is here we create a nice right triangle. So our right triangle looks like this. We have 18, we have 36, but we don't know the hypotenuse. We have both of the legs though. Those are your two given values here. So you can use Pythagorean theorem. You have the legs, so that's your A and your B. So 18 squared plus 36 squared, A squared plus B squared, equals your C squared. This would be C in this case, your hypotenuse here. So you can use your calculator. 18 squared is 324. 36 squared, you should get 1,296. That equals C squared. When you add those two together, you get 1,620 equals C squared. But if we want C, we need to take the square root. So C equals the square root of 1,620. So the square root, 1,620, we should get C is equal to, and we're going to round to the nearest tenth here. That's what we're told to round to. So it'd be 40.2, and we're in the unit of yards. So that distance diagonally across the rectangular garden is 40.2 yards. A lot of the time with these type of problems, drawing a picture really helps, because that'll tell you if you have the legs or if you have the hypotenuse and what you're looking for. You need to identify where the right triangle is. All right, on to our second word problem of the day. And this problem says, Aladdin is buying a new carpet. His new carpet is 12 feet wide and measures 20 feet diagonally across. How long is the carpet? Round your answer to the nearest tenth. So Aladdin, he has a nice carpet, and we're given a little picture of his carpet. It looks kind of like this. And we're told that it is 12 feet wide. So let's go ahead and say this is our width here, 12 feet wide, which if it's a rectangular carpet, it's going to be 12 and 12. And then it's 20 feet diagonally across. So diagonally across either way, we'll go this way this time. This is your 20 here, 20 feet diagonally across, say is a rectangular carpet, and we're trying to find out how long his carpet is. So this would be like your X, the length, and they would be the same on top or bottom. Notice how we make a couple of right triangles here. I'll use the one on the bottom. We have 12, 20, and we're looking for X. So this picture really helps us determine what we have. We have one of the legs, we have the hypotenuse, we're looking for the other leg. The other leg would be the length of that carpet here. So we know the leg we don't know squared plus 12 squared is equal to 20 squared. That's what we know. That's Pythagorean theorem. So X squared plus 144 is equal to, well, 20 squared is 400. So X squared, you should subtract your 144, and you'll end up with 256. When you take the square root of 256. So x equals the square root of 256. And we round that to the nearest tenth. Well, we don't need to because it's a perfect square. It is 16 squared. And that means the length is 16. We're in the units of feet here. So that means your x, your length, would be 16 feet. Again, the picture is going to help you out a lot. All right, on to our next. And this one, again, pictures are really useful. This one says, Justin hikes 7 miles south and then 6 miles west. How far is Justin from his starting point? So, this one will help to draw a picture. We have Justin, and he is going to hike. Here's Justin. And he's going to hike, let's see, 7 miles south. So his starting point's here, and he's going 7 miles south. Northeast, southwest. If we don't know, here's our little compass for us. So he's going 7 miles south. So this was 7 miles. And then from there, he goes 6 miles west. So west is in this direction. And what's nice about working with these directions here is if you go south and then west, like they're going to form right angles right there. Like that's a nice right angle. And we want to know how far Justin is from his starting point. So when he finishes, he's over here now. So now here's Justin. He's moved. And we want to know how far he is from the starting point, like what's the shortest distance. If he had to like sprint back to it, well, his starting point would be right here. Notice by making this little drawing for us, we have a nice right triangle. 7 is one of your legs, 6 is the other leg. The hypotenuse, we'll call it C. That is his shortest distance back to his starting point. So we can set up Pythagorean theorem. 7 squared plus 6 squared is going to equal our C squared. 7 squared is 49, plus 6 squared is 36. So 49 plus 36, and I'm going to take the square root of that. So our C squared, we should end up with 85, which means C is the square root of 85. And when you go ahead and evaluate the square root of 85, you should end up with 9 point, and we'll round to the nearest tenth, 2 and miles away. So when he's at his final spot over here, he is 9.2 miles away from his starting point. If he wanted to go straight back, that would be his shortest distance. All right, we have 3 more we're going to do. And these are kind of applying Pythagorean theorem in different ways now, and using it to find certain values and various missing measurements. So our first one, we have this figure drawn. So this one, we're given a figure, we don't have to draw it on our own. And this we have, this is 8 inches, this is 6 inches, this is x inches, and this is 14. Our goal is to find the value of x here. So notice we have a couple of right triangles. We have this first right triangle over here to the left, and then we have this little right triangle to the right if we block out the first one. In the right triangle to the right, we're given the hypotenuse, we're looking for one of the legs, we also don't know the other leg. So we have a little bit of work to do, we have to get that leg first. In this triangle to the left, we're given one of the legs and the other leg, but we don't know the hypotenuse. So the hypotenuse of this smaller triangle here, that hypotenuse is actually the leg of the other triangle. So we need to find the hypotenuse of this one, which then will be used as a leg in the other triangle. So let's focus on, I'll redraw it a little smaller, this triangle right here, the 8 and 6. So to find this value, we'll call it C, this would be C. You would do 8 squared plus 6 squared is equal to C squared, and this is 64 plus 36 is C squared. So C squared is 100, so C would equal the square root of 100, which hopefully we know is 10, and we're in inches here. So this value C, well, this is actually 10. So we have the value of 10 there. So C was 10. But we're still not done because we're looking for X now. So let's go back, take away some of that work. We found out this was 10. Now I'm going to focus on this other triangle, and the other triangle looks like this. we have this is x. We just found out this side is 10 and this is 14. So focusing on this triangle, well, we have one of the legs, we have the hypotenuse, we're looking for the other leg. So 10 squared plus x squared is equal to the hypotenuse squared. So we should get 100. We don't know what x squared is yet. And 14 squared, we should get 196. So x squared, we should end up with, when you subtract 100, x squared is equal to 96. So x is equal to the square root of 96, which when we round to the nearest tenth, x would equal 9.8, and we're still in the unit of inches. So that would be your value of x down here. It's 9.8 inches, and that's what we were looking for. So this one you had to do a little bit of work, use Pythagorean theorem twice, use it to find one of the legs, and then once you found the leg, then you can use it to find the other leg over here. Keep in mind the relationship. The leg, or the hypotenuse of the first triangle was the leg of the second triangle. Sometimes you have to take a step back and think about what you have and what you're looking for. All right, so we have two more. Our next one, we're given this triangle, looks like this. And we are asked to find the perimeter of the triangle rounded to the nearest tenth. So we have 22 inches, 8 inches, and we don't have this side. So when you look at the triangle, we should notice we're given the hypotenuse and a leg. We don't know the other leg, we'll call it x for now. But we're given one of the legs, so 8 squared plus your x squared should be equal to your 22 squared. And when you do a little bit of evaluating here, you should get x squared plus 64 is equal to 484. Subtract your 64 from both sides. So x squared should equal 420. And then take your square root. So you take your square root of 420. You get x is equal to 20 points, and we'll round to the nearest tenth, 20.5. So this is 20.5, but that's not what we were looking for. That's just part of the steps to get what we're looking for. In the end, we're looking for the perimeter of the triangle. So to get the perimeter, we need to add together all the sides. So 22 plus 8 plus the 20.5, that would give us the perimeter. So when you add these together, 22 plus 8 is 30, plus 20 is 50.5. So the perimeter should be 50.5, and we're in the unit of inches here. And that would be our final answer. That's what we were looking for. All right, on to our last one. These can be a little tricky. All about seeing and finding the right triangles. So our last one, we're given a three-dimensional figure here. I'll do my best drawing of it. Looks like this. And we go down. This is our three-dimensional figure. And we want to find the distance. It's kind of hard to see. We want to find the distance from the bottom left corner, like right here. We want to find the distance from that all the way to this top right corner in the back. So we want to find this distance from the front left bottom to the back top right. So you're going like diagonally across like space. It's actually called the space diagonal. You're going not only diagonally up, but diagonally back as well. And we're given some information. This side is 5. This bottom is 5. And this is 12. They're all in the units of millimeters. Now we have a right angle down here, and this is a right angle here. This is like a nice little rectangular prism, meaning we have a bunch of right angles, which is nice. And it's also noted out that we have this guy right down here in the bottom. That's a diagonal, just flat across the bottom. So in order to find this distance, we'll call it x, that diagonally going back and up from the bottom left to the top right, we need to first figure out what this distance is here. We'll call it c. If we can figure out what this distance is, I'll show you how we can use that to find the x. So this distance, I'm going to redraw this little right triangle we have on the bottom, is 12 by 5, and then we'll have C. That's like the flat triangle on the bottom of this figure here. And if you do Pythagorean theorem here, well, you have two legs. And when you go ahead and evaluate, 25 plus 144 equals C squared. So C is going to end up being the square root of 169. So C will equal, well, it's a perfect square. C will equal 13. So this value C here is 13. I'm going to replace it, put in a nice 13. Now if we look to this other triangle, the one that kind of goes diagonally back, we know that that distance on the bottom is 13. We know the height going up is 5 here. And we're trying to find that value x going across. So we kind of have a right triangle. It just goes back diagonally. And we're trying to find x. Very similar to the one we had here, but one of our legs is a little bit larger. So 5 squared plus 13 squared is going to be equal to C squared. So 5 squared is 25, 13 squared is 169, and C squared we still have as C squared. When we add these together, we should get 194. That's going to equal your C squared, which means C is equal to the square root of 194. Let's clean that. And when you evaluate, oh sorry, this shouldn't be C, this should be X. We call the x here. So x would equal, well, when you take the square root of this, a little bit less than 14. We'll round it off to 13.9, and we're in the units of millimeters. So that would be your value of x. Kind of hard to see in this one, it's three-dimensional, but there's a flat triangle on the bottom, and then there's a right triangle going diagonally back. A little tougher to see, but if you can find right triangles in problems, they can make finding missing values a lot easier. And some problems that might seem impossible, Pythagorean theorem is usually a really nice way to make them possible to find. Alright guys, have a good day.